Let's discuss rational equations and then complete some examples that involve rational equations. A rational equation is an equation, so it will have an equal sign, with a rational expression for one or more terms. And a rational expression would be like this: 1 divided by x squared plus x, where you have a polynomial in the numerator and a polynomial in the denominator. When we're working with rational equations, we need to always make sure that we restrict our domain to eliminate any values. In this case, our first case, we're using variable x, so that it would make our denominator 0. So we would never want our denominator to be 0 because that would make that fraction undefined. So when I start, I like to already have my denominators in factored form. So I would leave that first fraction as it is, and the second fraction as it is, and I would write over here on the right side of the equal sign, I would factor that x to the front and make it x times x plus 1. So we have a least common denominator of x times x plus 1, and if we set each one of these equal to 0, we know that x can't be 0 and x plus 1 can't be 0. So that means x can't be -1. So we're going to make sure that when we're done with our answer that we don't use -1 and we don't use 0, because those are restricted. Let's go ahead and multiply all of our terms by that common denominator. So I'm going to leave in blue what was original, and I'm going to kind of leave some space here so I have room to multiply. And if I'm distributing x times x plus 1 to the numerator, to everything in this equation, I'm actually going to multiply it by each one of the terms. Okay, so let me go ahead and write down what we initially had. And I'm going to show in red that I'm distributing that x times x plus 1 to each one of the fractions. And I'm multiplying it to the numerator, x times x plus 1 in each case. So in the first fraction, we can see, and we can simplify common factors, x plus 1 and x plus 1 would reduce to 1, and we would be left with a factor of x times 4x plus 3. In the second fraction, we would simplify the x over x to be 1, and we would have a 2 times x plus 1 left. And in the third fraction, both the x over x reduced to 1 and the x plus 1 factors reduced to 1, leaving us with a 1. Now let's simplify. I'm going to distribute here. I have 4x squared plus 3x plus, distribute again with a 2, 2x plus 2 equals 1. And I'm going to start to get like terms together. So 4x squared, I'm going to put the 3x and 2x together to make 5x plus 2 equals 1. A little more space over here. And in my head, I'm already saying I'm going to go ahead and move the 1 over to the left to get it equal to 0. So we should have 4x squared plus 5x plus 1 equals 0. And we're going to, if it's possible to factor it, if you don't want to factor it, you could use quadratic formula. Lots of ways that we could solve here, but those are two. So 4x and x. I'm going to factor this just by trial and error. I'm already thinking ahead that I probably want 4x times a 1 to make 4x, and then a 1 times x to make 5x, and everything here would be plus to keep the addition positive and the multiplication positive. You can do a quick distribution to make sure that it goes back to the original. I'm going to set each one of these factors equal to 0. That's our multiplicative property of 0, and solve. Solve each one individually. And so we have an answer of -1/4 and -1. But going back to check, we can go back and check in our original expression and our original equation, or we can go back and check where we said our domain is restricted. So we could check, could negative 1/4 be okay in this denominator? Yes, it would not make it 0. Would negative 1/4 be okay here? Yes. And again, in our factored form for the third fraction, it would also work. Notice that we had already restricted negative 1. So when we're checking negative 1, we're going to say that one's not possible because it makes our denominator 0. So in this case, we only have one answer of negative 1/4. Let's take a look at example 2. Same idea, I'm going to factor 3m squared minus 14m plus 8, and it's really not a mystery that a lot of times these are the factors, not always, but I'm going to start there and use that and check to see if that would multiply back. So our 3m squared checks off. Outer, we would have a negative 12n. Inner, we'd have negative 2m, which does total the negative 14m, and last times last is a positive 8, so that does check off. So our least common denominator is going to be 3m minus 2 and m minus 4, and we can also go ahead and we're going to restrict our domain to make sure that those denominators would not equal 0. And that's nice to kind of have ahead of time before we finish solving. But if you forget this step, you can always check at the end. Now our m can't be equal to negative 2/3, and our m can't be equal to 4. So let's go ahead and I'm going to write out in factored form our equation. And I'm going to leave enough space so that in a different color, I can distribute that common denominator. And without showing it back to this stage where I showed it distributing to each term, I'm going to go right to this shortcut step where I'm going to go ahead and just distribute it and show it next to each term. So our common denominator is going to be 3m minus 2 times m minus 4 in the numerator. And then we're going to simplify and see what's remaining. After this step, we should no longer have fractions. Everything should be in the numerator only. 3 times 3m minus 2, and I'll distribute later, and 1 times m minus 4. So I'll go ahead and distribute to see what we have. 9m minus 6 and m minus 4. Combining like terms, 9m plus m makes 10m, and negative 6 minus 4 is negative 10. And I can solve that equation. Let me go ahead and get the m alone. And it looks like I get 20 equals 10m. And solving, we get m equals 2. Notice going back to where we had our restrictions, that's not anything that was restricted, and you could go back and check the denominators of the original factors, and it would work in each of the denominators. It would not leave the denominator 0. And so m equals 2 is our final answer. Let's take a look at example 3. Using variable a, same idea, we're going to look at the denominators in factored form. The denominator of the first fraction and second fraction are both factored already. The third one factors to a minus 2 and a plus 2. And so our least common denominator is going to be a minus 2 and a plus 2. And if we're looking at our domain restrictions, we know a minus 2 can't be 0 and a plus 2 can't be 0. So this one tells us a can't be 2, and this one tells us a can't be negative 2 when we're done with our and looking at our final answers. Like before, I'm going to go ahead and write down each term, and I tend to leave space in between so that I can then in my next step distribute that common denominator of a minus 2, a plus 2 to the numerator. And then simplify and see what we have left. So in the first term, we have 3 times a plus 2, In the second term, we end up with 1 times a minus 2. And in the third term, both denominators end up reducing, and we just have a 12. So I'm going to distribute 3a plus 6 and 1a minus 2 equals 12, and then start to simplify. So it looks like I have 3a plus 1a is 4a, a 6 minus 2 is a 4, and then I'm going to keep going to solve. 4a equals 8, divide by 4, and I get a equals 2. But keep in mind that a can't equal 2, because if we put that back into that first fraction, 2 minus 2 would make that denominator 0 and the fraction undefined. So this one's not possible in our domain, and we don't have any other solutions, so our answer is no solution. Let's take a look at example 4. Something that helps me when I work on subtraction is I'm going to move this minus sign in front of the 5, so make it plus negative 5. That way I don't end up forgetting to distribute the negative with the 5. So looking at a common denominator, it looks like we have a denominator of 1, of y plus 3, and over here on the right, we actually have y plus 3 twice. Y plus 3 times y plus 3. So our least common denominator is going to have 2 factors of y plus 3. And just for ease, I like to actually show both of them. And then our restricted domain is going to say that y plus 3 can't be 0, which tells us that y can't equal negative 3. Let's go ahead and write out our 3 fractions. And remember, I'm writing that as negative 5 over y plus 3. And then in red, I'm going to distribute that common denominator of y plus 3 times y plus 3 to each term. And finally, y plus 3 times y plus 3. Start to reduce. In the first fraction, nothing reduces, so we just have y plus 3 times y plus 3. In the second fraction, we end up with, remember that was a negative 5 times y plus 3. And in the last fraction, we have a 6. I'm going to start to distribute. In the first multiplication, we have y squared. Outer is a 3y, inner is another 3y, and last is a 9. Distribute the negative 5 to make negative 5y, and negative 15 equals 6. I'm going to start to get like terms together. So I'm going to put together the 3y and 3y to make 6y, and then a negative 5y would make a 1y. And then a 9 and a negative 15 would make a negative 6 equals 6. I'm going to move the 6 over to get our quadratic equal to 0, and I get y squared plus y minus 12 equals 0. And then here we can factor or use quadratic formula. This one looks pretty quick to factor. Y plus 4 times y minus 3 equals 0. And set each one equal to 0 and solve. So I get y equals negative 4 and y equals 3. So notice that 3 is allowed. It was negative 3 that was restricted from our domain. So both of these are answers, y equals negative 4 and also y equals 3. Let's take a look at a work rate problem. Before we do that, I want to take a look at distance equals rate times time, and a couple of examples that might be familiar to us. So if you're driving 68 miles per hour for 7 hours, how far did you drive? Well, to find our distance, we're going to take our rate times our time. So I'm going to write 68 miles per hour as 68 miles per as my fraction bar, 1 hour, times, because we're going to take our rate times our time is 7 hours, and I'm going to write that in the numerator, so I'm just going to really emphasize the denominator of 1. I can reduce the hour label, hours over hours reduces, and so we end up getting 68 miles times 7 ends up a total of 476, and the only label left is miles, which makes sense because we were looking at a distance. If you drive 30 miles in 45 minutes, what's your driving rate? So I'm going to take that distance equals rate times time formula, and I'm going to solve for rate, which means I need to divide both sides by time. So I get distance divided by time equals rate. So I'm going to take the distance of 30 miles. I'm going to divide it by the time. They said 45 minutes. And then we're going to reduce. So I can reduce both of these by 15. So 30 divided by 15 is going to end up being 2 miles. And 45 divided by 15 is 3 minutes. So we can write this as 2 miles every 3 minutes, or you could write it as 2/3 miles per minute. And they would mean the same thing. If you mow the lawn in 2 hours, what is your rate? Now here we don't have a distance, we actually have an amount completed. So if we're looking at rate equals distance over time, we're just going to look at that as rate equals, instead of distance, the amount completed over time. So in this case, our rate is going to be 1 lawn is completed every 2 hours, our time. And so our rate is 1 lawn every 2 hours. That's going to help us in our work rate problems in a minute. So again, when we're looking at rate, we're looking at how much is completed, our distance, over time. Example 5. One printer can do a job 3 times as fast as another printer. Working together, both printers can do the job in 5 hours. How long would it take each printer working alone to do the job? It helps me to create a little bit of a chart. So here I'm going to have printer 1, and I'm also going to have printer 2. And on the top, I'm going to look at doing my distance, rate, and time. So I'm going to look at their time alone, because that's what I was given up here, how long it took one person to mow the lawn. And that's going to help me come up with the rate, the time they work together, and the amount completed. And then I'm going to fill in what I know. Okay, so we know printer 1, or one printer can work 3 times as fast as another. So I'm just going to assign printer 1 to be X hours. Okay, and then printer 2 is going to be the one that is going to be 3 times more. So actually printer 1 is faster. So just kind of keep in mind, if X is 1, printer 1 finishes in 1 hour, and printer 2, it takes 3 times as long. So 3 times 1 is 3 hours. So one printer 1, is 3 times faster than the second printer. What is the rate of printer 1? Printer 1 is going to finish 1 job every X hours. And printer 2 is going to finish 1 job every 3x hours. That's our, like what we did up here with our rate, with the amount completed over time. Their time together, in the problem, it says together they're going to do the job in 5 hours. How much is completed? Well, in our first row, we're just looking at printer 1, so the amount completed is going to be our rate times our time. So the rate for the first printer is 1/x times the time working together is 5 hours. So 1/x times 5 is going to be 5/x when simplified. Looking at printer 2, the rate was 1 job every 3x hours. And it's still going to work only 5 hours, because after 5 hours, the printing job is finished. It doesn't need to keep going. So its amount completed is 5/3x. Now, using our table, I like to write out my equation in words. So we have the amount completed by printer 1 plus the amount completed by printer 2 And that's going to equal the one job, or the amount completed together. And they're going to finish one printing job together. So the amount completed by printer 1 was our 5 over x when we simplified it. The amount completed by printer 2 was 5 over 3x when simplified. And again, they're going to equal one job finished. And now we have our rational equation, and we can look at a least common denominator of x. And keep in mind, 3 times x can be thought of as the factor 3 times the factor x. So we don't need an x squared. We only need x to the first power to be a common denominator. So 3 times x is our common denominator. Thinking ahead, we would also know that x equals 0 is restricted from our domain. So multiplying each one of these by that common denominator, 3x, and don't forget to multiply it to every single term in your equation to make sure that you've balanced your equation, we can simplify, and we can have 5 times 3 is 15. And then here the 3 over 3 reduces to 1, and the x divided by x reduces to 1, and we get 5. And then 1 times 3x is 3x. Simplifying 15 and 5 is 20, and dividing we get 20/3. Now 20/3 is the amount, let me write that 3 a little bit better. 20/3 is the amount for, when we were looking at it, printer 1 takes 20/3 hours. If it's helpful to you, you could write that as a mixed number. So that would be 6 2/3 hours for printer 1, just to kind of give it a number that's maybe easier to think of. So a little bit more than 6 hours, but less than 7. Printer 2, we said, was 3 times x. So 3 times our 20/3 reduces to 20 hours. So the printing job would take printer 2 alone 20 hours. So printer 1 will finish in more than 6 hours, and printer 2 would do the job in 20 hours, each of them by themselves. But if they work together, they would be able to complete the job, it said, in 5 hours. And that ends example 5.